Overproduction of uric acid in the body can be an indication of cell breakdown. This may be an advanced indication of illness such as gout, leukemia, or lymphoma. Over a period of months, an adult male patient has been taking 7 blood tests for uric acid. The mean concentration is X bar 5.43, and the dilution can be assumed to be normal with a population standard deviation of 1.75. Because we're given a population standard deviation of 1.75 and the underlying distribution is normal, any population size, including a population of 7, should be good enough. And so that's to find the confidence interval. We simply go into the calculator. Remember that the salt confidence interval does not work with your standard normal. You put in your sample size of 7. You put in the mean of 5.43. You put in the standard deviation of 1.75, and then you put in the confidence level 90%. Again, part of the reason why I like using calculator.net is that it not only gives you the answer, the upper and the lower limit, but it also gives you the formula on how it is calculated. And so again, this is the critical value, Z, 0. Of a 90% interval, standard deviation over the square root of n. If you look this number up, you get 1.645. You multiply that by the standard deviation over the square root of the sample size. And this number right here is going to be your margin of error. Remember, your margin of error is the product of these two terms. And so that's how you get, this is your lower limit, this is your upper limit, your lower limit and your upper limit, and your margin of error is this right. Okay, all of them have been rounded to 2 decimal places. You can also find the margin of error by simply taking the mean and subtracting it from the upper limit. Because remember, upper limit plus the margin of error, the mean plus the margin of error gives us the upper limit. All right, again, down here they give you more information on the confidence interval on how to calculate. So again, the necessary conditions. Sigma is known and it's normal distribution. If it wasn't a normal distribution, you'd need a large N over 30. And if sigma is unknown, you have to use the student T distribution. Here, result right here, we have 90% confidence that the true value is between the interval right here, between these two numbers. And then to find this one, 8, you use this formula right here, N is equals to Z critical, that is, so still 9% confidence interval, yeah. So that's going to be your the Z critical is going to be a 1.645 rounded. Sigma is going to be the 1.75, and then your E is going to be the error they give you of 1.2. Plug all those in, you square the answer, and then you round up. Remember, you always round up, and that should give you the value 8. All right, just into salt. If you go to distribution calculators, normal distribution, you put in your mean, standard deviation, 0 and 1, and you put in it between, and you put in 90% confidence interval, 0.9. That will give you the Z critical value.